Most people can't answer basic questions about US geography, but get ready for 30 up-to-date geography revelations that will make you the smartest person in any room. Using the most current 2025 statistics and discoveries, I'm revealing geographical secrets that sound too strange to be true, but are completely verified. Take Alaska's mind-bending ability to simultaneously exist in both the eastern and western hemispheres, defying everything you think you know about compass directions. From states that break the rules of east and west to natural formations that contain percentages of the world's resources you won't believe, these facts will transform you into a geography expert who can amaze anyone with legitimate knowledge they've never heard before. Alaska's triple geographic crown. Here's a geography quiz that stumps 99% of people. Which single US state holds the record for being the northernmost, westernmost, and easternmost state all at the same time? This sounds completely impossible because basic compass directions should prevent any location from being both the easternmost and westernmost point of a country. The answer defies everything you think you know about American geography. Alaska accomplishes this seemingly impossible feat through a geographic anomaly that breaks all the rules. The key lies in the Aleutian Islands, a chain of volcanic islands that extends over 1,200 miles from the Alaska Peninsula into the Pacific Ocean. These islands stretch so far west that they actually cross the 180th meridian, which serves as the international date line separating the western and eastern hemispheres. Recent surveys confirm that several Aleutian Islands extend beyond the 180th meridian into the eastern hemisphere. Attu Island sits at coordinates 172.9 degrees east longitude, placing it technically in the eastern hemisphere alongside countries like Japan and the Philippines. This crossing of the international date line means Alaska exists in both hemispheres simultaneously, making it the easternmost state when measured by hemispheric standards. GPS surveys track slowly drifting island positions as geological activity continues to shift their exact coordinates. For travelers crossing between these islands, this hemisphere split creates the bizarre experience of jumping from Tuesday to Wednesday simply by moving between neighboring islands. Map makers face constant challenges updating charts, as these remote locations technically exist on different calendar days. Meanwhile, Alaska's northernmost point at Point Barrow reaches 71.38 degrees north latitude, and its westernmost point in the Western Hemisphere sits at Amatignac Island at 179.06 degrees west longitude. Alaska shatters every assumption about American geography by existing in two hemispheres while claiming three directional records. This geographic impossibility demonstrates how the international date line creates situations where traditional compass directions become meaningless. But Alaska isn't the only state that challenges our geographic assumptions with surprising continental connections. The Africa distance paradox. Which American state sits closest to the African continent? Most people automatically think of Florida because it extends far south toward the equator, or maybe they consider Texas due to its position along the Gulf of Mexico. The assumption makes perfect sense since Africa sits across the Atlantic from America's southeastern coast, and southern states should logically provide the shortest route across the ocean. The geographic reality completely contradicts this logical assumption. Maine, located in the far northeastern corner of America, actually sits closer to Africa than any southern state, including Florida. This counterintuitive fact emerges from mathematical proof using the most advanced 2025 satellite measurement technology available to geographers today. Current GPS coordinates place Quoddy Head in Maine at the exact eastern tip of the United States. Using 2025 precision mapping systems, scientists have calculated the distance from this Maine lighthouse to El Jadida, Morocco at precisely 3,154 miles across the Atlantic Ocean. These measurements utilize satellite positioning accurate to within centimeters, providing unprecedented precision for intercontinental distance calculations. Florida's distance to the same Moroccan coastal city tells a completely different story. Advanced 2025 mapping data shows that Miami sits approximately 4,025 miles from El Jadida, Morocco. This means Maine beats Florida by a substantial 871 miles when measuring the shortest route to African soil, despite Florida's obvious southern advantage. Because the Earth is round, east-west separation can outweigh north-south distance. While Florida extends much farther south and appears closer to the equator that runs through Central Africa, Maine's northeastern position places it significantly farther east. The African continent stretches much farther north than most people realize, with Morocco extending well above the Tropic of Cancer. The 871-mile difference between Maine and Florida demonstrates how spherical geometry creates unexpected geographic relationships that flat maps cannot accurately represent, proving that our planet's curved surface makes northeastern Maine America's gateway to Africa. These surprising continental connections reveal just how dramatically geography can challenge our assumptions about where Americans actually choose to live. America's lopsided population reality. The distribution of Americans across their vast continent tells an even more startling story about geographic influence on settlement patterns. Picture an imaginary line drawn across the American continent that reveals one of the most shocking demographic secrets about where people actually live in this country. This invisible boundary exposes a population imbalance so extreme that it challenges everything most Americans believe about their own nation's settlement patterns. The population divide line near San Antonio serves as America's ultimate demographic separator, running just west of San Antonio, Texas, and extending north through the Great Plains. This geographic marker splits the United States into two drastically unequal halves that tell the story of American settlement in stark mathematical terms. The 2025 census data reveals a population split that has remained remarkably consistent over recent decades. Current statistics show that 80% of all Americans live east of this San Antonio line, while just 20% occupy the western portion of the country. This enduring pattern demonstrates how historical settlement patterns continue shaping where Americans choose to establish their communities. Multiple geographic and historical factors perpetuate this eastward demographic pull. The eastern half contains the original colonial settlements that formed the foundation of American civilization. New York City houses 7.9 million residents in a densely packed metropolitan area, while Denver serves as a major western hub with significantly fewer people spread across much larger distances. These contrasting examples illustrate how eastern cities developed extensive infrastructure, educational institutions, and economic networks over centuries of continuous growth. Geographic obstacles continue limiting western settlement despite modern transportation and communication advances. The western portion includes vast mountain ranges, desert regions, and protected federal lands that restrict large-scale residential development. National parks, forests, and wilderness areas occupy enormous territories that remain permanently off-limits to population centers. The staggering reality emerges that roughly 4/5 of the American continent remains virtually empty of permanent residents, making the United States one of the most demographically lopsided developed nations on Earth. This massive western expanse raises fascinating questions about exactly how much American territory has been deliberately preserved from development entirely. America's expanding protected empire. The federal government maintains direct control over a staggering amount of American territory through an organized preservation system that most citizens never fully grasp. The national park system represents something much larger and more complex than the handful of famous parks that appear on postcards and travel websites. This extensive preservation network encompasses every type of protected landscape and historical site imaginable, creating a comprehensive system that safeguards America's most important natural and cultural treasures. The 2025 count reveals that 423 areas now exist within the national park system, representing a continuous expansion of conservation efforts across multiple decades. This number includes traditional national parks alongside numerous other categories of protected land that serve different preservation purposes and management strategies. From national parks to seashores and battlefields, this network covers every corner of America. Current 2025 data shows the system has added several new designations and expanded existing boundaries over the past year, reflecting ongoing commitment to land preservation despite competing economic pressures. These recent additions include both natural landscapes and historic properties that meet strict criteria for national significance. This massive preservation effort represents one of the world's largest coordinated conservation programs undertaken by any single nation. These areas cover over 84 million acres, encompassing desert wilderness, mountain ranges, coastal areas, prairies, forests, and urban historic districts across all 50 states and several territories. The scope demonstrates enormous public engagement with these protected areas, supporting thousands of jobs in gateway communities while maintaining public access to these national treasures. Americans have dedicated an impressive portion of their continental territory to permanent preservation, creating a conservation legacy that protects natural wonders and historical sites for future generations. Yet even this massive federal preservation system pales in comparison to the natural resources contained within America's borders, including freshwater reserves that dwarf most people's understanding of what single geographic features can actually hold. Superior's freshwater monopoly. Lake Superior represents the crown jewel of this freshwater concentration, holding resources that dwarf most people's comprehension of what a single geographic feature can contain. Most people would guess major river systems like the Amazon or Nile when asked what holds the largest percentage of Earth's fresh surface water, or perhaps think about massive ice sheets in Antarctica. The reality involves a concentrated freshwater reservoir that sits entirely within North American borders, containing an almost unbelievable portion of the planet's available fresh water. The scale of freshwater resources concentrated in this one location defies comprehension when you consider how water scarcity affects billions of people worldwide. While entire continents struggle with limited freshwater access, this single body of water contains enough fresh water to supply human civilization for generations, representing a natural treasure of global significance. Lake Superior stands as the ultimate freshwater giant, serving as a massive reservoir that holds resources crucial to both regional ecosystems and global water security. This Great Lakes System component extends across 31,700 square miles of surface area, making it the largest freshwater lake by surface area in the world. The 2025 updated measurements using advanced satellite technology show that Lake Superior contains approximately 10% of the world's fresh surface water. This staggering statistic means that one American lake holds the same amount of fresh water as entire river systems, smaller seas, and countless lakes combined across other continents. Current satellite-based calculations reveal that Superior contains roughly 2,900 cubic miles of fresh water. These precise measurements utilize advanced monitoring technology that tracks water levels and volume changes with unprecedented accuracy, providing scientists with detailed data about this massive freshwater resource. Retreating glaciers at the end of the last ice age carved out Superior's massive basin through centuries of geological activity. These glacial forces created a depression so large and deep that meltwater from the retreating ice sheets filled it completely, forming the freshwater giant that exists today. One American lake rivals entire continents for freshwater storage capacity, demonstrating how geographic forces shape water distribution across vast territories. Yet this massive freshwater reservoir represents just one example of how geographic boundaries control the movement and destination of water across the American landscape. The Continental water splitter. Mountain ridges and elevated terrain create an invisible but powerful force that determines the fate of every raindrop across the continent. What geographic boundary controls whether precipitation will eventually reach the Pacific Ocean, Atlantic Ocean, or Gulf of Mexico, based purely on which side of elevated terrain the rain happens to land? The Continental Divide represents this ultimate watershed boundary that has operated for millions of years without human intervention. This natural barrier consists of mountain ranges and elevated terrain, forming a continuous ridge system extending from Canada to Mexico, creating distinct drainage basins that channel water toward different ocean destinations through simple gravitational flow patterns. This ridge system directs water flow across vast distances through networks of rivers and streams that eventually reach different oceans thousands of miles from their mountain origins. Water falling east of the divide flows toward the Atlantic Ocean or Gulf of Mexico, while precipitation landing west of the ridge travels toward the Pacific Ocean through completely separate river systems. The 2025 updated mapping data from the U.S. Geological Survey utilizes advanced satellite technology and ground-based surveys to track the divide's precise route through the Rocky Mountains with unprecedented accuracy. These detailed maps reveal how the divide influences watershed management and water resource allocation across multiple states, providing essential data for understanding continental water distribution. Climate change has created measurable effects on water flow patterns along the Continental Divide, according to current research. Rising temperatures and altered precipitation patterns are changing the amount and timing of water flow, leading to increased runoff, modified river courses, and shifts in water resource availability that affect both ecosystems and human populations dependent on these water systems. The divide influences weather patterns and ecosystems by acting as a barrier that affects air mass movement and precipitation distribution. This creates diverse habitats supporting different plant and animal species on either side of the ridge, making the Continental Divide a critical factor in biodiversity and conservation efforts. Elevation changes measured in feet can determine whether water travels thousands of miles to reach completely different oceans, demonstrating how geographic forces create extreme environmental conditions in unexpected American locations. America's below sea level desert. These extreme environmental conditions reach their most dramatic expression in America's most unlikely desert location. What place in North America sits lower than sea level, while simultaneously being one of the hottest places on Earth? Most people assume that desert regions exist at high elevations where thin air and mountain conditions create extreme temperatures. The reality involves a geographic anomaly that defies basic assumptions about how elevation and climate interact in the American landscape. This location challenges everything you expect about American geography by combining below sea level conditions with desert environments that produce some of the most extreme temperatures ever recorded. The combination sounds impossible because most people associate low elevations with coastal areas and moderate climates rather than scorching desert conditions. Death Valley's Badwater Basin represents this below sea level phenomenon, sitting at a remarkable depression that creates unique environmental conditions found nowhere else in North America. This basin holds the distinction of being the lowest point in the Western Hemisphere, creating a natural laboratory for extreme geological and climatic processes. The 2025 updated elevation measurements using advanced GPS technology confirm that Badwater Basin sits at precisely 282 feet below sea level. These measurements utilize satellite positioning systems that provide accuracy within centimeters, ensuring precise documentation of this extreme elevation. The basin's position creates a natural bowl that traps heat and intensifies already harsh desert conditions. Geological forces created this dramatic depression through millions of years of crustal stretching and thinning in the region. Tectonic activity caused the Earth's crust to pull apart, creating a rift valley that continues sinking today. This process formed a basin so deep that it extends far below ocean level despite being located hundreds of miles from the nearest coastline. Current research shows that Death Valley continues experiencing subsidence, meaning the basin keeps sinking deeper. The 2025 climate data reveals record temperatures that regularly exceed 120 degrees Fahrenheit during summer months. The basin's below sea level position traps superheated air that cannot escape, creating furnace-like conditions that make this one of Earth's most inhospitable environments. This extreme landscape demonstrates how geographic forces create isolated pockets of environmental extremes, yet these dramatic features represent just individual points within America's vast interconnected system of natural waterways. America's massive river network. The scope of flowing water across America reaches dimensions that challenge human comprehension. What total distance would you cover if you could somehow walk along every single river and stream that flows through the United States? The scale of waterways crisscrossing the American continent creates a network so extensive that most people cannot grasp the actual mileage involved in this liquid transportation system. America's river network represents one of the most impressive hydrological systems on Earth, connecting every region of the country through an intricate web of flowing water. These waterways range from massive rivers like the Mississippi and Colorado to tiny mountain streams that flow only during spring snowmelt, creating a comprehensive system that touches virtually every corner of the continental United States. The 2025 updated count from the U.S. Geological Survey reveals that over 250,000 rivers and streams stretch approximately 3.5 million miles across the country. This staggering total represents a distance that equals roughly 14 round trips to the moon or 140 trips around Earth's equator, demonstrating the incredible scope of America's flowing water resources. Recent advancements in satellite mapping technology have significantly enhanced the precision with which scientists can measure river length and characteristics. These technological improvements enable more accurate assessments of river health and provide detailed data on river morphology, flow patterns, and surrounding ecosystems that were previously impossible to obtain through ground-based surveys alone. This vast river network supports diverse ecosystems ranging from wetlands and forests to prairies and mountains, providing habitats for countless species of wildlife, while serving crucial economic functions for agriculture, transportation, and freshwater supply. The Mississippi River Basin alone spans 1.2 million square miles and drains water from 41% of the United States, encompassing 31 states. The 2025 data on river health monitoring shows ongoing conservation efforts that address environmental challenges, including pollution from agricultural runoff and climate change impacts. The USGS actively monitors water quality, flow rates, and sediment transport while tracking how rising temperatures affect water levels and flow patterns across the entire system. These millions of miles of flowing water eventually reach America's coastlines, where the true scale of geographic measurements becomes even more surprising than most people imagine. Alaska's coastline dominance. Alaska's coastal measurements reveal dimensions that dwarf every other state's maritime boundaries combined. Which state possesses more coastline than you could possibly imagine? Most people think of California with its famous Pacific beaches or Florida with its Atlantic and Gulf coasts when considering extensive shorelines. The assumption makes sense because these states feature prominently in coastal tourism and maritime commerce, creating the impression that they dominate America's coastal geography. Alaska's coastal statistics reveal a geographic reality that completely overshadows every other state's shoreline measurements. This northern territory contains more oceanic boundary than seems mathematically possible for a single state, creating a coastal dominance that defies reasonable expectations about American geography. Alaska possesses more coastline than all other 49 states combined, a fact that sounds impossible until you examine the precise measurements. The state's oceanic boundaries stretch over 34,000 miles of intricate shoreline that winds through countless bays, inlets, and island chains across 3 different ocean systems. The 2025 updated measurements utilize advanced satellite mapping technology that provides unprecedented accuracy in coastal boundary calculations. These sophisticated systems can track coastline changes with precision measured in meters, offering detailed documentation of Alaska's massive maritime perimeter that previous surveying methods could never achieve. Alaska's complex island chains and fjords create this massive coastline through geographic formations that multiply the actual shoreline distance exponentially. The Aleutian Islands alone contribute thousands of miles of additional coast, as each island adds its own perimeter to the state's total measurement. Deep fjords carved by ancient glaciers create intricate coastal patterns that extend far inland, dramatically increasing the total shoreline calculation. The comparison between Alaska and the rest of America reveals staggering proportions. While states like California measure approximately 840 miles of coast and Florida contains roughly 1,350 miles of shoreline, Alaska's 34,000-mile measurement exceeds the combined total of every other state by a substantial margin. Alaska's coastal supremacy demonstrates how one state can possess more oceanic boundary than the entire rest of the nation. Yet this massive perimeter represents just the outer edge of a continent that contains its own precise mathematical center point. America's geographic bullseye. Determining the exact mathematical center of this vast territory requires sophisticated calculations that account for every irregular coastline and border. Where exactly would you find the precise spot where America's landmass achieves perfect equilibrium if you could balance the entire United States on the head of a pin? This geographic challenge demands calculating the point where the nation's physical boundaries create mathematical balance. The complexity of locating America's geographic heart involves advanced surveying techniques that must process millions of coordinate points along complex borders and coastlines. Unlike finding the center of a perfect circle or square, determining the geographic center of a country requires calculations that can handle the irregular shape of the continental United States. Kansas serves as home to the continental United States Geographic Center, a distinction that places America's physical heart in the rural farmland of the Great Plains. This location sits far from major population centers or famous landmarks, representing instead the mathematical balance point of the entire continental landmass. The 2025 updated coordinates using GPS precision measurements place the geographic center at approximately 39 degrees 50 latitude and 98 degrees 35 longitude. These coordinates utilize satellite positioning technology that provides accuracy within centimeters, ensuring the most precise representation of America's physical center possible with current technology. The center has shifted slightly over decades due to improved mapping techniques and more accurate surveying methods. Advanced satellite technology and digital mapping systems have refined the exact coordinates as scientists gain better understanding of precise coastal boundaries and territorial measurements that affect the calculation. Geographic centers differ fundamentally from population centers, which track where most people actually live rather than physical landmass balance. The population center shifts continuously as Americans migrate between states and regions, while the geographic center remains fixed as a mathematical constant based on unchanging territorial boundaries. A simple monument marks this significant location near Lebanon, Kansas, providing visitors with a tangible marker representing the nation's physical heart. The monument sits in rural farmland approximately 20 miles north of the Kansas-Nebraska border, creating an unexpected destination for geography enthusiasts seeking America's mathematical middle. This precise Kansas location demonstrates how mathematical calculations can identify exact positions that define national characteristics. Yet America contains an even more remarkable geographic convergence, where state boundaries create an entirely unique meeting point. The unique four-state meeting point. The Four Corners Monument represents the ultimate expression of surveying precision, creating the only location in America where four different states meet at a single coordinate point. Where else can you stand in Arizona, Colorado, New Mexico, and Utah simultaneously. This geographic phenomenon sounds impossible because state boundaries typically follow natural features like rivers or mountain ranges that prevent such precise convergence. This rare occurrence exists nowhere else in the United States, making it a singular destination that attracts visitors specifically because of its mathematical precision. Most state boundaries involve only two states meeting along extended border lines, but this location defies normal boundary patterns by bringing together four separate jurisdictions at one exact spot. The 2025 updated survey data utilizing advanced GPS technology confirms the monument's precise location at coordinates 36 degrees 5,956, 3N latitude and 109 degrees 0242, 6W longitude. These measurements provide accuracy within centimeters, ensuring the monument represents the true mathematical convergence point of the four state boundaries with unprecedented precision. Early surveying efforts in the 19th century created slight historical inaccuracies due to primitive surveying tools and challenging terrain conditions. The remote desert location presented significant obstacles for surveyors working with basic instruments, resulting in minor positioning errors that persisted for decades before modern technology could correct them. Modern GPS technology has refined the exact coordinates to eliminate historical surveying discrepancies. Current positioning systems provide highly accurate measurements that verify the monument's location while correcting previous inaccuracies that occurred during the original boundary surveys conducted over a century ago. The site maintains cultural significance for the Navajo Nation and other Native American tribes whose ancestral lands encompass this region. This area represents important heritage connections and traditional territories that predate the establishment of state boundaries by thousands of years. The remarkable rarity of this four-state convergence demonstrates how mathematical precision creates unique geographic destinations. Yet this single meeting point represents just one aspect of America's complex territorial coordination challenges that extend far beyond the continental United States. America's time zone complexity. Managing schedules across America's vast territorial reach creates coordination challenges that most citizens never fully comprehend. How many time zones does the United States actually span when you count every territory and possession under American control? Most people think of the continental United States with its four main zones from Eastern to Pacific, but the true scope of American time management extends far beyond the familiar boundaries that most citizens experience in their daily lives. The complexity of American time coordination involves managing schedules and operations across vastly different geographic regions that operate on completely separate daily rhythms. This temporal challenge affects every aspect of federal operations, business communications, and national coordination in ways that most Americans never consider when they check their local time. The United States spans 7 distinct time zones when including all territories and possessions under American jurisdiction. These zones stretch from the Eastern Time Zone on the Atlantic coast all the way to American Samoa in the South Pacific, creating a temporal empire that covers nearly half the globe through American territorial control. The 2025 updated information shows these territories maintain their distinct time zones despite technological advances that could theoretically unify American timekeeping. American Samoa operates 5 hours behind Eastern Standard Time, while Guam sits 14 hours ahead of Eastern Time, creating scheduling complexities that span nearly an entire day. Territories like Guam and American Samoa extend America's time reach across the Pacific Ocean into regions where American military bases, federal operations, and civilian populations must coordinate with mainland United States activities. These Pacific territories require federal agencies to maintain 24-hour communication capabilities and scheduling systems that accommodate extreme time differences. The practical challenges this creates for national coordination affect everything from military communications to federal court proceedings. Government agencies must schedule meetings that accommodate participants across 7 different time zones, often requiring some participants to join calls during overnight hours or early morning periods. America's time zone empire demonstrates the remarkable geographic reach of American territory, where the nation maintains sovereignty across temporal boundaries that span from Atlantic dawn to Pacific midnight. Yet beneath America's most famous landscapes, even more dramatic forces operate on geological timescales that dwarf these daily coordination challenges. The supervolcano beneath Yellowstone. Yellowstone National Park conceals geological forces that dwarf every surface attraction that draws millions of visitors annually. What hidden power lies directly beneath America's most beloved national park? Most visitors focus on the geysers, hot springs, and wildlife that make this destination famous worldwide, never considering the massive underground systems that create these surface features through forces that operate on an almost incomprehensible scale. The park sits atop a massive supervolcano caldera measuring approximately 55 by 20 miles across the landscape. This enormous depression formed after previous major volcanic eruptions and subsequent ground collapse, creating a geological feature that ranks among the largest supervolcano calderas on Earth and subjects scientists to intense ongoing study. The 2025 updated monitoring data from the U.S. Geological Survey shows continuous tracking of the Yellowstone magma chamber through advanced seismic tomography and geochemical analysis. These sophisticated systems include seismographs detecting ground movement, GPS stations measuring ground deformation, and gas monitoring stations analyzing volcanic gas composition to identify subtle changes indicating increased volcanic activity. Current scientific monitoring utilizes a comprehensive network of cutting-edge technologies providing real-time data analysis. The USGS collaborates with research institutions to enhance monitoring systems while maintaining seismic sensors, GPS stations, and gas analysis equipment throughout the park region, creating unprecedented surveillance of this geological giant. The scale and potential impact extends far beyond regional effects if a major eruption occurred. Scientists estimate that a supervolcano eruption could release vast amounts of ash and gas into the atmosphere, potentially affecting global climate patterns and causing widespread disruption across multiple continents through atmospheric changes. The 2025 research on eruption probabilities indicates that while major eruptions remain extremely unlikely in any given year, the geological processes continue evolving as scientists study magma movement and heat release patterns. Millions of visitors annually enjoy recreational activities directly above one of Earth's most powerful geological forces. Yet this underground giant represents just one component of North America's remarkable concentration of natural resources. The Great Lakes water monopoly. America's freshwater resources concentrate in ways that challenge every assumption about continental water distribution. Where does North America store the vast majority of its available freshwater? Most people might guess that freshwater spreads evenly across the continent through various rivers, lakes, and underground sources. The geographic reality reveals an extraordinary concentration that defies these logical assumptions about water distribution. The Great Lakes system represents a freshwater concentration unlike anywhere else on the planet. This interconnected network of 5 massive lakes creates a freshwater reservoir that dwarfs other continental water sources through sheer volume and geographic scale. The system spans over 94,000 square miles across the northern United States and southern Canada, forming the largest freshwater system by surface area anywhere on Earth. The Great Lakes contain an astounding 84% of North America's fresh surface water, making them the undisputed freshwater champions of the continent. This percentage means that the vast majority of available freshwater across the entire North American landmass sits concentrated in these 5 interconnected basins, creating a geographic monopoly that shapes regional ecosystems and human settlement patterns. Current 2025 satellite monitoring technology provides unprecedented accuracy in measuring the Great Lakes' total water volume. Advanced remote sensing systems track water levels with precision measured in centimeters, revealing that these lakes collectively hold over 6 quadrillion gallons of freshwater. This represents approximately 21% of the entire world's surface freshwater concentrated in one geographic region. This freshwater treasure supports ecological diversity that includes wetlands, forests, and countless species, while serving crucial economic functions through shipping, tourism, and resource extraction. The lakes provide drinking water for over 40 million people across both countries, making them essential to regional survival and prosperity. The Great Lakes Compact provides legal protection, ensuring sustainable management across multiple jurisdictions, while monitoring environmental health indicators that track the system's ongoing health and stability. 5 connected lakes hold more than 4/5 of an entire continent's freshwater, yet this massive surface water concentration represents just one aspect of America's hidden geographic treasures that extend deep beneath the surface. Kentucky's underground marvel. Kentucky contains the world's most extensive underground network ever documented through scientific exploration. Where would you find cave passages that stretch farther than the distance between major cities? Most people think of famous cave networks in Europe or Asia when considering massive underground formations. The reality involves an American cave system that extends beneath a single state's landscape through distances that seem physically impossible for subterranean passages. Underground exploration represents one of humanity's most challenging scientific endeavors because mapping subterranean passages requires specialized equipment and expert knowledge of cave safety protocols. Modern cave exploration combines traditional spelunking techniques with advanced surveying technology that can accurately measure passage length and create detailed three-dimensional maps of complex underground networks. Mammoth Cave in Kentucky stands as the world's longest-known cave system, holding this record through documented scientific exploration and precise measurement techniques. This underground network extends beneath Kentucky's landscape through limestone bedrock that provides ideal conditions for extensive cave formation over geological time periods. The 2025 updated data shows that explored passages now exceed 400 miles of mapped underground routes throughout the Mammoth Cave system. These measurements utilize advanced GPS technology and laser surveying equipment that provides unprecedented accuracy in cave mapping, revealing intricate passage networks that connect across vast underground distances. Recent discoveries continue expanding the known extent of this cave system as exploration teams document previously unknown passages and chambers. Ongoing exploration efforts employ cutting-edge technology, including 3D mapping systems and underground communication devices that enable safe exploration of remote cave sections while maintaining contact with surface support teams. Limestone erosion created this underground network through millions of years of groundwater slowly dissolving bedrock along natural fracture lines. This geological process carved extensive passage systems that branch and interconnect throughout the region's limestone foundation, creating the complex maze that exists beneath Kentucky's surface. Current research focuses on cave ecosystems that support unique species adapted specifically to underground environments. Scientists study blind fish populations and specialized bat colonies that thrive in cave conditions, documenting how these animals evolved to survive in permanent darkness. Kentucky's underground marvel demonstrates how single geographic locations can contain record-breaking features that challenge our understanding of what's possible within state boundaries. Yet some states achieve even more remarkable distinctions by claiming multiple impossible geographic records simultaneously. Alaska's Geographic Triple Crown. Alaska demonstrates how territorial scale creates geographic dominance that transcends normal state boundaries. How can one state simultaneously claim 3 impossible directional records that seem to violate basic geography principles? Alaska achieves something that sounds mathematically impossible by holding titles for northernmost, easternmost, and westernmost state positions all at once. This geographic phenomenon defies logical assumptions about how compass directions work across American territory. Alaska dominates multiple geographic categories through its massive size and unique positioning that extends across vast oceanic distances. The state covers over 663,000 square miles of territory that stretches from the Arctic Ocean to the Pacific, creating opportunities for record-breaking measurements that smaller states cannot achieve through pure geographic scope. Alaska serves as America's northernmost state through Point Barrow, which reaches 71.38 degrees north latitude into Arctic territory. The easternmost designation comes from Pochnoi Point on Semisopochnoi Island, while Amatignac Island claims the westernmost position. These extreme coordinates demonstrate how Alaska's territory spans impossible distances across multiple hemispheres simultaneously. The 2025 updated GPS measurements show Alaska's northernmost point at precisely 71 degrees 2320 N latitude, while the easternmost coordinates place Pochnoi point at 179 degrees 46 E longitude. The westernmost measurement reaches 179 degrees 09 W longitude at Amatignac Island, creating a geographic spread that encompasses nearly the entire width of the Pacific Ocean through the Aleutian chain. The Aleutian Islands create this geographic anomaly by extending over 1,200 miles westward from the Alaska Peninsula across the international date line. These volcanic islands cross the 180th meridian that separates western and eastern hemispheres, allowing Alaska to exist in both hemispheres simultaneously while maintaining continuous territorial sovereignty. Alaska's unmatched geographic supremacy demonstrates how one state can monopolize directional records through sheer territorial scope that extends across multiple time zones, hemispheres, and oceanic regions in ways that no other American state can match. Yet geographic dominance extends beyond territorial boundaries to encompass the massive human populations that concentrate within individual state borders. California's population powerhouse. California demonstrates how individual states can achieve population concentrations that rival entire nations on the global stage. Which single American state contains more people than developed countries that most Americans consider major world powers? The demographic scale of certain states challenges basic assumptions about population distribution and reveals concentrations of humanity that compete with countries possessing centuries of established civilization and international influence. California's demographic dominance extends far beyond typical state population comparisons into territory that competes with entire nations. This western state has accumulated residents at a pace and scale that transforms it from a regional entity into a population powerhouse capable of influencing national politics, economics, and cultural trends through sheer numerical strength. California contains more people than all of Canada, a comparison that reveals the staggering concentration of population within American state boundaries. While Canada spans nearly 4 million square miles across the world's second-largest country by land area, California packs more residents into just 164,000 square miles of territory along the Pacific coast. The 2025 updated population figures show California reaching nearly 40 million residents, while Canada maintains approximately 38 million people across its entire continental territory. This demographic comparison means that one American state exceeds the population of America's northern neighbor by over 2 million people, despite occupying significantly less geographic space. California surpasses numerous other countries in total population, including Poland, Ukraine, and Argentina. The state accounts for almost 12% of America's entire population, making it a demographic giant that influences everything from congressional representation to consumer market trends through pure numerical dominance. This massive population concentration creates extraordinary economic implications that extend far beyond state boundaries. California would rank as the fourth or fifth largest economy globally if it operated as an independent nation, generating economic output that rivals major world powers through the productivity of its nearly 40 million residents. One American state functions as a population superpower containing more residents than most countries, yet America also contains geographic features that achieve record-breaking status through the opposite extreme of remarkable smallness. Montana's miniature river record. Montana contains a waterway that challenges every assumption about what qualifies as a river through its remarkably compact dimensions. Where would you find the world's shortest river, and how could any waterway possibly qualify as a river when it measures shorter than a football field? Most people imagine rivers as massive flowing systems like the Mississippi or Amazon that stretch across continents and states. The geographic reality involves a waterway so compact that you could walk its entire length in under a minute, while still meeting every technical requirement that defines a true river. This geographic oddity exists in Big Sky country, where Montana's vast landscapes typically feature expansive prairies and towering mountain ranges rather than miniature water features. The contrast between Montana's reputation for enormous geographic scale and this tiny waterway creates an unexpected juxtaposition that highlights the surprising diversity found within American geography. The Roe River in Montana holds the official title as the world's shortest river, measuring exactly 201 feet from source to mouth. This remarkable waterway connects Giant Springs to the Missouri River near Great Falls, creating a flowing connection between two larger water bodies despite its incredibly brief journey across the Montana landscape. Technical criteria for river classification require flowing water, defined banks, and connection to larger water systems rather than minimum length requirements. The Roe River meets these standards through continuous flow from Giant Springs, clearly defined channel boundaries, and direct connection to the Missouri River system, qualifying it as a legitimate river despite its miniature dimensions. Competition for the shortest river title has created ongoing controversy as other locations propose alternative candidates for this geographic record. Various waterways across different countries have challenged the Roe River's supremacy, leading to debates about measurement techniques and classification standards that determine official recognition. Current conservation efforts focus on protecting the springs that feed this unique waterway while maintaining the natural conditions that preserve its flowing characteristics. Environmental monitoring ensures that human activities and climate changes do not affect the delicate water sources that sustain Montana's record-breaking tiny river system. America's geographic extremes extend beyond measurable features into phenomena that challenge our basic understanding of how the physical world operates around us. Washington's gravity-defying hill. Washington state contains a location where the fundamental laws of physics appear to malfunction in ways that confuse every visitor. Where can you witness cars appearing to roll uphill against gravity's consistent downward pull? Most people assume that gravitational forces consistently pull objects downward along slopes, making uphill movement impossible without external force applied to overcome natural physics. Prosser, Washington hosts one of America's most famous gravity hill optical illusions, where this captivating phenomenon has attracted curious travelers for decades. This roadside attraction draws visitors who want to experience the apparent defiance of gravity firsthand, creating a popular destination that continues fascinating people through its perceptual trickery and memorable encounters that challenge logical understanding. The scientific principles behind this visual deception involve complex interactions between human perception and environmental cues that mislead the brain's interpretation of slope direction. The brain relies on visual references, including the horizon line, trees, and road characteristics, to determine gravitational direction and slope angles. But when these cues become distorted or absent, complete misinterpretation occurs. The surrounding landscape creates this convincing effect through specific topographic features that distort normal visual references. The horizon line and nearby objects provide misleading information that causes the brain to misinterpret the true grade of the roadway, leading to the compelling illusion of uphill movement when objects actually roll downhill along a slight grade that remains invisible to human observation. Current research on optical illusions reveals how easily the human brain can be misled by visual information when environmental cues conflict with actual physical reality. Scientists continue studying how perceptual systems process landscape information and why certain topographic configurations create such convincing illusions that override logical understanding of gravitational forces. Current visitor data shows continued tourist interest in this perceptual anomaly, with travelers specifically seeking out gravity hills as unique roadside experiences that provide unforgettable encounters with geographic trickery. The fascinating reality demonstrates how geography can manipulate human perception through visual deception. Yet some geographic locations create even more dramatic separations between nations across remarkably narrow distances. The Domed Islands International Split. Two isolated islands in the Bering Strait create the most dramatic international boundary in the world. What location represents the closest point where American and Russian territory nearly touch each other across international waters? Most people imagine vast oceanic distances separating these two superpowers, making direct contact seem impossible across the Pacific. The geographic reality involves a narrow gap that creates one of the world's most strategically important border zones. The Domed Islands occupy this strategic position, with Big Domed belonging to Russia and Little Domed claimed by the United States. These two isolated communities exist closer to each other than many neighboring towns within the same country, yet they represent different nations separated by international law and geopolitical boundaries across just 2.5 miles of frigid Bering Strait waters. The 2025 updated data reveals increased strategic importance as Arctic shipping routes expand due to melting sea ice. Both nations maintain enhanced surveillance capabilities and border patrol operations in this region, utilizing advanced radar systems and regular patrol flights to monitor maritime activity. The islands serve as crucial observation posts for tracking vessel movements through the increasingly navigable Arctic waters. Winter ice conditions create a temporary land bridge between the two countries when temperatures drop sufficiently to freeze the strait completely. During these periods, the water surface becomes solid enough to theoretically support foot travel between Russian and American territory, though crossing remains strictly prohibited under international agreements. Little Domed residents face extraordinary challenges living in this isolated Arctic environment. The community of approximately 80 residents must import virtually all supplies by helicopter or boat during brief summer months when weather permits transportation. Harsh conditions include months of darkness, extreme cold, and complete isolation from mainland services. The international date line creates an additional layer of complexity by running directly between the islands, placing Big Domed nearly 24 hours ahead of Little Domed despite their close proximity. This temporal separation adds diplomatic complications to an already sensitive international boundary. The remarkable proximity demonstrates how geography creates situations where isolated communities represent the closest contact points between nations. Yet America contains even more impressive examples of isolation and scale hidden completely beneath the surface. Kentucky's underground world record. Deep beneath Kentucky's landscape lies a subterranean network that dwarfs every other underground exploration achievement in recorded history. What cave system represents the most extensive mapped underground passages ever documented by scientific exploration? Most people think of famous European cave networks or massive mining operations when considering underground systems, but the reality involves an American cave system that extends farther beneath the Earth than seems physically possible within a single geographic location. The scale of subterranean exploration required to map these underground passages challenges every assumption about what exists beneath our feet. Modern cave exploration combines traditional spelunking techniques with advanced surveying technology that can accurately measure passage length while creating detailed three-dimensional maps of complex underground networks that remain completely invisible from the surface. Mammoth Cave in Kentucky stands as the world's longest-known cave system, holding this record through documented scientific exploration and precise measurement techniques. This underground network extends beneath Kentucky's landscape through limestone bedrock that provides ideal conditions for extensive cave formation over millions of years of geological activity. The 2025 updated exploration data shows that mapped passages now exceed 400 miles throughout the Mammoth Cave system. These measurements utilize advanced GPS technology and laser surveying equipment that provides unprecedented accuracy in cave mapping, revealing intricate passage networks that connect across vast underground distances previously unknown to researchers. Ongoing discoveries continue expanding the known extent of this cave system as exploration teams document previously unknown passages and chambers using cutting-edge technology. Recent expeditions employ 3D mapping systems and underground communication devices that enable safe exploration of remote cave sections while maintaining contact with surface support teams. Limestone erosion created this massive underground network through millions of years of groundwater slowly dissolving bedrock along natural fracture lines. This geological process carved extensive passage systems that branch and interconnect throughout the region's limestone foundation, creating the complex maze that exists today beneath Kentucky's surface. Current research focuses on unique species that have adapted specifically to underground environments. Scientists study specialized fish and bat populations that thrive in cave conditions, documenting how these animals evolved to survive in permanent darkness. Kentucky's underground empire demonstrates how single locations can contain record-breaking features that challenge our understanding of scale. Yet America also harbors ancient life forms that achieve remarkable longevity through completely different biological strategies. Utah's ancient living giant. Utah conceals an organism that redefines our understanding of what constitutes a single living entity. What represents Earth's largest living organism, and where would you find this ancient life form that most people walk past without recognizing its true nature? Most people think of massive whales or giant sequoia trees when considering the biggest living things on our planet. The reality involves an organism that hides in plain sight across over 100 acres of Utah landscape, while maintaining genetic unity through an invisible underground network. This ancient life form masquerades as a typical forest grove that appears completely ordinary to casual observers. Visitors see individual trees scattered across the landscape without realizing they're viewing a single organism that has survived for tens of thousands of years through shared resources and coordinated growth patterns that connect every visible tree through underground systems. Pando represents this massive aspen grove in Utah that functions as one enormous organism rather than separate trees. This clonal colony consists of approximately 47,000 genetically identical trees that share resources through a single massive root system spanning over 100 acres of Utah forest land, creating biological unity on a scale that challenges normal concepts of individual organisms. The 2025 updated research shows Pando faces significant health challenges that threaten its long-term survival. Current studies reveal declining overall health due to grazing pressure from deer and elk that consume young shoots, preventing regeneration while climate change creates additional stress through altered precipitation patterns and rising temperatures that affect the grove's traditional growing conditions. This grove represents an astounding 80,000 years of continuous life, making it one of Earth's oldest living organisms. The trees share nutrients, water, and genetic material through their interconnected root network, allowing the organism to survive environmental challenges that would destroy individual trees by redistributing resources across the entire system. Current conservation efforts include installing protective fencing to exclude grazing animals, while researchers develop strategies to enhance climate resilience. Scientists study how individual stems communicate and coordinate growth while maintaining genetic identity across thousands of connected trees. Utah's ancient living giant demonstrates how nature creates massive organisms through hidden underground connections, yet some American locations harbor forces that operate through entirely different destructive mechanisms that refuse to stop burning. Pennsylvania's underground inferno. Centralia, Pennsylvania harbors America's most persistent environmental disaster in the form of an underground coal fire that has burned continuously since 1962. What represents the nation's longest burning fire that has refused extinguishment for over 60 years. Most people think of forest fires or building fires when considering major American fire disasters. The reality involves a subterranean inferno that creates an environmental catastrophe, transforming entire communities into uninhabitable wastelands. This underground disaster operates beyond normal firefighting capabilities because traditional suppression methods cannot reach the source of combustion buried deep beneath the surface. The fire spreads through interconnected passages that provide unlimited fuel while generating toxic gases that poison the air and destabilize the ground above the burning coal seams. The mine fire began in 1962 and continues consuming underground coal deposits across the region, representing one of the worst mine fires in United States history. This subterranean blaze creates a permanent disaster zone that has persisted through multiple decades of containment attempts and government intervention efforts. Current 2025 data shows the fire continues spreading through an extensive network of abandoned coal mines beneath Centralia and surrounding areas. Scientists estimate that substantial coal reserves remain unburned, ensuring the fire will continue for potentially another century or more. The exact boundaries remain difficult to map due to the fire's deep underground location and complex spreading patterns through mine tunnels. This disaster transformed Centralia from a thriving community of over 1,000 residents into a virtual ghost town. The fire's toxic fumes and ground instability forced mass evacuations as homes became uninhabitable due to dangerous carbon monoxide levels and collapsing foundations. By 2025, fewer than 10 residents remain in a community marked by surface cracks, smoking vents, and collapsed areas. Current monitoring efforts include ongoing air quality testing and ground stability assessments, while containment strategies have included digging fire breaks, water injection systems, and sealing access points. However, the fire's extensive reach through underground networks makes complete suppression nearly impossible. Pennsylvania's eternal underground fire demonstrates how environmental disasters can create permanent damage that defies human control. Yet America contains geographic features that challenge assumptions about what can exist in completely unexpected locations. Wyoming's landlocked island collection. Wyoming demonstrates how mountain geography creates surprising water features that most people never associate with landlocked states. How can a completely landlocked mountain state possibly contain dozens of islands when it sits hundreds of miles from the nearest ocean? Wyoming seems like the last place you would expect to find islands, given its location in the heart of the American West, surrounded entirely by other landlocked states. Mountain states typically feature rugged terrain, high elevation peaks, and continental climates rather than the water bodies necessary for island formation. Wyoming's reputation centers on vast open spaces, cattle ranching, and dramatic mountain ranges that seem completely incompatible with island geography that most people associate with coastal regions and oceanic environments. Wyoming contains a remarkable collection of over 30 named islands scattered throughout its numerous lakes across the state. These islands exist within freshwater lake systems that dot the Wyoming landscape, creating isolated land masses that function as true islands despite their continental mountain setting far from any oceanic influence. The 2025 updated geological surveys show that Wyoming's lakes contain these islands primarily in larger water bodies, including Yellowstone Lake, Jackson Lake, and Flaming Gorge Reservoir. Advanced mapping technology has identified and cataloged these island formations with unprecedented precision, documenting their exact coordinates and ecological characteristics through satellite imagery and detailed topographic analysis. Glacial activity during previous ice ages created these inland island systems through massive geological processes that carved lake basins and left elevated terrain that became islands when the basins filled with water. Retreating glaciers deposited sediment and rock formations that created the topographic variations necessary for island formation within these mountain lake environments. These isolated habitats provide crucial ecological importance by creating unique environments that support specialized plant and animal communities separated from mainland ecosystems. Islands within Wyoming's lakes serve as refuges for species that require specific habitat conditions while contributing to overall biodiversity throughout the region. Wyoming's unexpected island empire demonstrates how landlocked mountain geography creates dozens of true islands hundreds of miles from any ocean. Yet America's relationship with oceanic waters extends far beyond what most people realize when considering the nation's true maritime reach. America's three-ocean border. The continental United States touches three separate oceanic systems that most Americans never fully appreciate when considering their nation's maritime power. How many oceans actually border the United States when you count every body of water that touches American territory? Most people immediately think of the Atlantic and Pacific Oceans that define America's eastern and western coasts. This assumption makes perfect sense because these two major oceans dominate American geography lessons and coastal tourism, creating the impression that America maintains a two-ocean maritime presence. America's extensive maritime boundaries extend far beyond the familiar Atlantic and Pacific coastlines into Arctic waters that most Americans never consider part of their national geography. This additional oceanic access creates strategic advantages and economic opportunities that transform America from a two-ocean nation into something much more powerful on the global maritime stage. The United States borders three distinct oceans: the Atlantic, Pacific, and Arctic. This tri-ocean access grants America unparalleled maritime reach across multiple hemispheres and climate zones, creating opportunities for trade routes, resource extraction, and naval operations that exceed the capabilities of nations limited to fewer oceanic boundaries. Alaska provides America's crucial gateway to the Arctic Ocean through its northern coastline that extends into waters traditionally considered inaccessible to major powers. This Arctic access positions America strategically within a region experiencing rapid transformation due to climate change and emerging shipping opportunities that create new economic possibilities. The 2025 updated data shows America's total coastline stretches over 34,000 miles across all three oceans, with Alaska contributing the vast majority through its complex network of islands, inlets, and fjords. Current research on climate change impacts shows Arctic waters experiencing accelerated ice melting that opens new shipping routes while creating both opportunities and challenges for coastal communities. America's three-ocean advantage represents remarkable geographical positioning that provides maritime dominance across multiple oceanic regions, ensuring strategic access that few nations can match. Yet this extensive oceanic reach creates an interesting contrast with states that face the complete opposite challenge of accessing any ocean whatsoever. Nebraska demonstrates the extreme opposite of maritime access through its unique geographic positioning. Which state faces the greatest challenge reaching ocean access due to its location in America's heartland? Most people might assume that states like Nevada or Wyoming experience the most isolation from seaports due to their western mountain locations. The geographic reality reveals a different situation involving degrees of separation that create unprecedented transportation and economic challenges. The concept of degrees of separation from ocean access creates varying levels of geographic isolation across American states. Some landlocked states border coastal states that provide relatively direct access to seaports, while others face multiple barriers that complicate trade routes and increase transportation costs significantly. Nebraska holds the distinction as the only triply landlocked state in the United States, meaning it sits surrounded entirely by other landlocked states. This unique positioning creates a geographic situation that exists nowhere else in America, where multiple layers of land barriers separate the state from any oceanic access point. Being surrounded by other landlocked states means that Nebraska cannot reach seaports through direct routes to neighboring coastal states. Instead, goods must travel through multiple state boundaries before reaching ports, creating complex logistics chains that increase transportation time and costs while adding multiple potential disruption points. This geographic challenge creates significant obstacles for trade and transportation that affect every aspect of Nebraska's economic activity. The state relies heavily on road and rail networks that must traverse multiple states to reach seaports, making transportation costs substantially higher compared to coastal or border states with direct port access. Nebraska's economy faces particular challenges due to this geographic isolation, especially affecting its dominant agricultural sector. Higher transportation costs for exporting agricultural products reduce profit margins for farmers and ranchers while limiting access to global markets that could diversify the state's economic base. Current data shows that the federal government's $62 billion infrastructure allocation for 2025 could indirectly benefit Nebraska through improvements to transportation networks in neighboring states. The state's economic well-being depends heavily on these external transportation systems and the policies of surrounding states that control crucial trade routes. Nebraska's triply landlocked status creates transportation dependencies that no other state experiences. Yet American geography contains even more surprising coincidences that emerge from completely unexpected linguistic patterns. The rhyming capitals coincidence. Two American state capitals share a remarkable phonetic connection that emerged through completely separate historical processes. Can you name the only state capitals that rhyme with each other? This linguistic puzzle stumps most geography enthusiasts because state capitals typically follow naming patterns based on historical figures, geographic features, or cultural references rather than phonetic similarities. Boston and Austin represent the only rhyming state capitals in the United States, creating a unique phonetic pairing that spans from New England to the Southwest. These cities achieved their rhyming status through completely different historical naming processes that occurred centuries apart and thousands of miles away from each other, making their linguistic connection even more remarkable. The etymology reveals distinct origins that highlight the coincidental nature of their shared sound. Boston derives its name from Boston, Lincolnshire, England, reflecting the English heritage of Massachusetts Bay Colony settlers who named their new settlement after their homeland. Austin honors Stephen F. Austin, known as the Father of Texas, who played crucial roles in Texas settlement and development during the early 19th century. These cities present fascinating contrasts despite their shared rhyming names. Austin currently ranks as America's fastest-growing major city with a metro area growth rate of 25.84%, driven primarily by technology industry expansion, including major operations from Apple, Google, and Tesla. Boston maintains a more established economy focused on education, healthcare, and finance, with a metro area growth rate of 13.69% that reflects different demographic trends. Current 2025 demographic data shows Austin's median age at 35 years compared to Boston's 36.9 years, while housing values differ, with Austin averaging $303,300 versus Boston's $268,900. Austin's median household income reaches $80,852, compared to Boston's $78,706, reflecting the economic differences between these rapidly evolving metropolitan areas. This charming linguistic accident demonstrates how random historical processes create unexpected connections between distant cities through pure phonetic coincidence. Yet American geography contains even more impressive numerical coincidences involving massive quantities that challenge our understanding of scale. The Great Lakes water supremacy. The Great Lakes system demonstrates freshwater concentration on a scale that defies comprehension when compared to familiar geographic references. How much water would you need to fill the entire states of California and Florida if you could somehow create massive lakes covering their complete land areas? Most people cannot grasp the volume of water required to submerge two of America's largest states entirely. The Great Lakes contain more water than California and Florida combined would hold if both states were completely flooded. This comparison reveals the extraordinary scale of freshwater resources concentrated in the Great Lakes region, where natural geological processes created basins capable of storing volumes that exceed entire state territories through sheer capacity. The 2025 updated volume calculations using advanced satellite measurement technology show the Great Lakes collectively hold over 6 quadrillion gallons of freshwater. These precise measurements utilize remote sensing systems that track water levels with centimeter accuracy, providing unprecedented data on total volume fluctuations throughout seasonal cycles and long-term climate variations. This freshwater concentration carries enormous global significance, as the system contains approximately 21% of the world's surface freshwater. The Great Lakes provide drinking water for over 40 million people across both countries, while supporting extensive shipping networks that connect North American heartland regions to Atlantic Ocean trade routes through the St. Lawrence Seaway system. The Great Lakes Compact provides legal protection through binding agreements between 8 U.S. states and Canadian provinces that ensure sustainable management of these water resources. Current conservation efforts include advanced monitoring systems that track water quality and usage patterns, while implementing policies that prevent excessive withdrawal or contamination that could threaten this massive freshwater reserve. 5 connected lakes hold enough freshwater to completely submerge 2 major American states, creating a liquid treasure that exceeds the storage capacity of entire continental regions. Yet this massive surface water concentration represents just one example of how geographic measurements can produce completely unexpected results, depending on the methods used to calculate them. Hawaii's mountain height champion. Mountain height measurements reveal how different calculation methods can completely transform our understanding of which peaks truly dominate the landscape. How do you measure the world's tallest mountain when different approaches produce dramatically different results? Most people assume that Mount Everest automatically claims the height record because it reaches the highest elevation above sea level. The reality involves measurement techniques that reveal hidden giants whose true scale remains invisible when using traditional elevation standards. Different measurement approaches create dramatically different rankings for the world's tallest mountains. Sea level measurements show only the visible portion of mountains above ocean surface, while base-to-peak calculations include the entire structure from foundation to summit. These contrasting methods expose how measurement reference points determine which mountains qualify as the tallest on Earth. Mauna Kea in Hawaii towers over Mount Everest when measured from base to peak, revealing the true scale that sea level measurements conceal. While Everest reaches 29,031.7 feet above sea level, Mauna Kea extends over 33,000 feet from its ocean floor foundation to its summit, making it substantially taller than the famous Himalayan peak. The 2025 updated measurements confirm that Mauna Kea's total height from ocean floor to summit reaches approximately 33,500 feet. These precise calculations utilize advanced bathymetric mapping technology that accurately measures the underwater portion of the volcano, providing comprehensive data on the mountain's complete structure rather than just its visible peak. Sea level measurements show only 13,803 feet of Mauna Kea above ocean surface, while base-to-peak calculations include the massive underwater foundation that extends thousands of feet below sea level. The Hawaiian hotspot created this massive volcanic formation through millions of years of continuous eruptions that built layers of lava and ash. Hawaii's Hidden Height Champion demonstrates how measurement methods determine mountain rankings, revealing that the world's tallest mountain depends entirely on which reference point scientists choose for their calculations. Yet beneath America's surface, even more surprising discoveries await those who examine the ancient geological foundations that formed the continent itself. Alabama's African connection. Alabama contains geological evidence that directly connects American soil to the African continent through ancient formations that most people never realize exist beneath their feet. What physical remnant of Africa lies buried deep underneath Alabama's familiar landscape? Most Americans assume that Africa and North America exist as completely separate landmasses with no connections beyond shared oceanic boundaries. The reality involves ancient geological relationships that create direct physical links between continents through underground formations hidden beneath American territory. Geologists have discovered a substantial chunk of the African continent located deep beneath Alabama's surface, representing a geological remnant from the ancient supercontinent Pangaea. This African fragment exists as a buried formation that provides tangible evidence of continental connections that existed approximately 335 million years ago when all continents formed a single massive landmass. The 2025 updated geological research utilizes advanced seismic imaging and core sampling techniques to map the extent and composition of this buried African formation with unprecedented precision. Current studies reveal that this fragment maintains geological characteristics identical to formations found across modern Africa, providing definitive proof of ancient continental unity through direct physical evidence. Continental drift processes left this African fragment behind as Pangaea broke apart through massive tectonic forces that separated the continents over millions of years. Plate tectonics and mantle convection created the geological forces that drove continental separation, while leaving behind isolated fragments that preserve evidence of ancient connections between landmasses that now exist thousands of miles apart. Current research techniques employ sophisticated geological surveys that create detailed three-dimensional models of Earth's subsurface structure. Scientists use seismic waves and advanced mapping technology to identify buried formations and analyze their composition, revealing underground geological connections that remain invisible from surface observation. Africa literally hides beneath Alabama through this remarkable geological remnant that proves continents maintain physical connections to their ancient shared history. This discovery demonstrates how modern technology continues revealing surprising geographical secrets that challenge our understanding of the American landscape. These geographic discoveries showcase how America contains features that operate on impossible scales while hiding secrets beneath familiar landscapes. From Alaska's hemisphere-defying directional records to buried African continental fragments beneath Alabama soil, the United States harbors mysteries that continue surprising researchers who thought they understood American geography completely. The 2025 revolution in satellite mapping technology and AI-driven geological surveys keeps revealing new information about places Americans visit daily while refining measurements that seemed permanently established. Advanced seismic imaging uncovers underground formations, while precision GPS systems track changes measured in centimeters across vast territorial expanses. Your own community probably contains geographic anomalies waiting for discovery through these modern research techniques that make previously impossible measurements routine scientific practice. America's geographic complexity ensures that future technology will continue exposing hidden wonders that challenge our understanding of this remarkable continent.